Hopefully, Amina and Mona, your voices aren't too short.
I gotta shut my door.
It's all good. So I do have the chat window pulled open. So Mona, Amina, please feel free to type things into there in case anything comes up. I guess first things. How did I'm not sure if folks have taken a look at this already, or they are caught up in other work.
I've just read through it now quickly so I could like familiarize, but I haven't tried problems.
Okay. And Amina, Mona, feel free to type something if you guys are working through, you found an issue or anything like that.
I'm gonna go put those dogs in the garage. It's my girlfriend's and she's selling her house, so they're here.
Oh, okay.
I'll be right back.
Yeah, no worries.
No need to wait.
Sounds good. Nice, Amina. It looks like you got it done yesterday. It's fantastic. I found most of this relatively the same as some of the method stuff that we had to do earlier. There doesn't seem to be anything too out of the ordinary from sort of the stuff that we had to do throughout the assignments. It seems more like a refresher. I don't know if Amina, you kind of felt the same. I'm going to take the silence as a yes. Sorry. So Ryan, you're just saying how most of the work in this assignment does seem relatively fresh or similar to things that we've already seen throughout the course. Like I think we did like a tuition calculation.
Something that was almost the same, yeah.
Like a difference calculation, commissions calc. I think that was like assignment 7.
Like the general assignment's like a summary assignment of almost everything, I guess.
That's what it seems like.
Yeah.
So there wasn't anything groundbreaking here. I don't think there was any new concepts introduced here. It's just mainly just a repetition of stuff that we had already seen.
Just utilizing methods, I guess, basically for it all, as opposed to before we were putting it into mains and stuff sometimes in the other assignments, like the first times we had seen them.
Yeah, exactly. The one thing that did trip me up a little bit is the degrees and radians conversion here. So just pay attention.
I noticed that,
yeah. In 5 and 6, because I think the math.sine and math.cos, the expected value that they intake is radians. So you do have to make sure to convert from degrees to radians as a part of the method call, because it is asking for degrees in the method call. But the methods that you're using, so math.sine, math.cos, and math.tan, require radians. Oh, I see. I just saw your message, Amina. I have tried parts 5 and 6. It gets intense real quick.
Wonderful.
Sorry?
I said wonderful.
I mean, so I don't think we need to do 5 and 6 as a part of the course.
Oh, you mean, yes, sorry. I thought you meant 5 and 6 questions, but yes, he was going to give it as assignment 11, I guess, but he cut that out for time, I guess.
Yeah.
Yeah. And because it's crazy.
It gets pretty hard. There were, so some of them are not too nuts. Like this one is just, displaying, printing things in a single line, right? Which isn't crazy difficult. and this is sort of using a random number generator, which is stuff that we are familiar with as well. This is counting odds and evens, and just outputting sort of the count as yes or no. So again, stuff that we've seen. This one is this is when it starts getting a little bit odd.
Digit frequencies.
Yeah. So it's like it took some creativity, at least from my side, to kind of figure out how to do a frequency table. In concept, it's really easy, right? Because you can see it and then you can just count. Like, hey, I want to count, how many of certain things show up, right? But doing it in code was a little bit wonky. I guess since it's not going to be an assignment, if we want, I can share sort of how I approached it.
That'd be cool.
If you guys want.
Sure. So when you say frequency, like, you just mean the way it displays out? Like in terms of being simple, but in terms of how you had to code it?
Yeah, exactly. So
well, I'll see based on how you show it, I guess, too. I made a document where I cut those 2 sections out, like, and called it assignment. I'm not even looking at them.
Yeah.
But I would be interested to see how you approached it for sure. And because, like you say, we're not submitting it, you can show us.
Yeah.
You're allowed. So you did almost all of those?
So I did 5. I think this is 5 or 6. Yeah, this is 5. So like random int array, you're just creating an array of integers, right? I think this is like 15 items with from 0 to 10. So, relatively straightforward. Like all this stuff is just gluing together, like this one, gluing together stuff that we're already familiar with, have already seen. This one is, you generate random numbers and then you count how many odds and evens. The frequency calculator is what starts getting a little bit funky. So you generate a random series from 0 to 10, or from 1 to 10, sorry. And then you have to count the frequency, right? So for example, zeros, I have 1, 0. And then ones actually don't have any in my random generator, so I counted 0. 2, I have 1, 2, 3, 4, 5, 6. Right, so it's easy to visually count, but it was very strange to actually do it in code. So what I ended up doing is, let me just find the specific part.
Yeah, because you would have had to give instructions to the console basically to do your count, right?
Yeah, exactly. And what I ended up doing that I thought was somewhat elegant is setting up an array of size 10. So there's 10 objects in the array. So there's 10 objects in the array. So, index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I basically used the index as my frame of reference for the digit themselves. So if I found for each item in my my argument array, if it was a 0, that's the place that I would put the value into. Or sorry, that's the index of the array that I would modify, and I would increment it by 1. So if a 0 popped up, I would look for my array 0 and go, so that it all starts with 0, right? Oops. So if a 0 popped up, I would increment the one in the 0 index by 1. And then if if a 2 pops up, I would do the same. but on the 2. And then if another 0 popped up, I would increment on the 0 index, and then I would go from there. I know other programming languages like Python have things called dictionaries, which basically is a value key match. But I didn't actually spend too much time looking into this from a C# perspective. I'm sure there is a dictionary type concept where it's just instead of an index value pair, it's actually a key value pair. So you can define, car A is a Toyota. Car B is a Prius, which is also a Toyota, but regardless.
I was just gonna ask out of curiosity, because when you're saying you use the index as your reference, so were you using like, it goes 0, 1, 2, 3. Can you call like index name and then the 3 in bracket to give you that one? Or
yeah, exactly. So when you
okay.
like if I did, like if this was called my array,
you're going my array regular, or sorry, inside when you call it,
my
would be
array
like
5 would equal the 5th value. So
Yeah.
0, 1, 2, 3, 4, 5.
Gotcha.
Or this one. So it actually return this value. And right now it'd be 0. Which is how I could proxy using the index value as a pseudo key for my frequency check. But then it gets weirder from there, right? Because then you're using like the last digit. So you have to figure out a way to extract the last digit of a number, right? So, if it takes 105, you need to only look at the 5 as a part of your frequency calc.
Okay.
And then it gets into like ranges. So like I want the frequency from 0 to 9, and then 10 to 19. So it was a lot of trying to, at least 4, 5, and 6, I found were a lot of trying to find ways to backport into just having a single digit. So it was interesting, but it's probably not the most appropriate way of doing it.
I was curious with because you showed 5, 6. 6, when you said it was a range, or when you're calling for a range, I assume you could call it in a similar way with that range within your bracket call, or did you do it in like because I'm wondering with 5, when you only want the last digit returned, did you do that with a return that gave you just the 3rd digit, or like, I'm just curious of the difference in how you structured those, or if they were structured the same.
So it's actually structured very similarly, right? Because what I realized is, 105 or 284 or whatever. When you divide these by 10, the remainder will always be your last digit.
Okay.
Right. So then you can always,
that's
once
the kind of stuff
that,
I don't think of it intuitively.
And that lets you use basically this going forward, right? Because I think I just do a mod 10.
Yeah.
So it's exactly the same.
I wasn't sure if it was like, and I'm assuming there might be a way to do this, but like within a method, you could return like just the 3rd digit of a result or something like that. But that wouldn't even work if it was a bigger number. But I'm just curious, like I'm sure there's a method or you know what I mean, a process.
Yeah, I mean, so I can think of a couple ways. You could convert it to a string potentially.
Yeah, and then call that section or whatever. Call that.
Yeah, and actually, I don't know if I know in Python strings are essentially arrays. So you can do like,
Same
you
kind of
can
thing
pull
where
the
you can
last
put in the
character of
bracket.
a
Yeah.
string. And
Oh
I don't
yes,
know
because
if you
you
can
could.
do that in C#.
Yeah.
And then like number frequencies, I think, yeah, so I'd like round down and divide by 10. Or sorry,
Oh,
divide by
okay.
10 and then round down, which gives me the 10th digit, but this would break with like if it was in the hundreds. So it's
Yeah,
pretty,
you'd have to add conditions almost like if else within the thing or something for like where your calculation needs to correct, right?
yeah.
Like
I mean,
if you wanted it to work beyond 100 or whatever in different ranges.
Yeah. Alternatively, you can have like a massive case statement here that just has every single range that you want.
Yeah. That'd be better than if else actually.
But that would
Because
be,
you'd have more conditions.
it's still a little bit cleaner to read. But that's a lot of lines of code.
Yeah.
And after a certain point, it becomes difficult to read just because of the volume. And there's ones here that I literally don't know how to do, like distribution of letters in a string. Like I honestly am just like, I don't know how to do this.
I hate to say this, but it makes me feel better to see that there's something that he has that you couldn't figure out how to do. That is crazy.
It's just
though.
confusing.
Return the distribution of the letter in the string, so it would give you actually the number of the letter you're asking for, huh?
Yeah. So I mean, like I have something that quasi does it.
Yeah.
But it only works for like a string that has 10 different characters max. And if there's a lengthier string, or it has a lot of blanks in it, that it's just inefficient.
Yeah, you need because you need conditions for repetition, say like if s's were in the word twice or something, so that it wouldn't like break it, or it would just return the first, I guess. Maybe
it's less that. So like the logic that I took was I want to sort the string. So I want to break the string into characters. So I have individual letters, and then I want to sort it so that I have, it in order. And then basically, if the letter is the same as the next letter, then I'll increase the counter of that letter by 1. And then I keep increasing until I'm out of the same letter, and then I move on to the next letter. But it doesn't look good from an output perspective.
Okay.
And it's hard to read, and it's hard to follow, and all of that fun stuff. Some of the rest of it does get a little bit easier. I think this one is the outlier that I just couldn't parse. But like binary strings, or turning a string into a binary value, calculating a mortgage. Some of these, they're not complex from a code perspective. They're just more complex from a like a mental, like, how do I do this?
I was gonna say 12. Like I read 12. It's so short, but it's like, ooh, how many terms are needed to match math pi?
It's like 1 million.
Yeah.
No, like actually, it's like where's my thing? Where's my?
You did like an output for it and stuff, eh?
Yeah, like at 500 terms.
That's only the percentage accuracy.
I matched the first 2.
Wow.
I ran it with, I think, 500,000.
Wow.
And I matched like 3.
How long did that compile?
A long time.
Yeah, I was curious about that because I haven't run anything that's long. So I was like, how does it slow it down? I've had that in Python, but I've never had it slow down in C# just because I'm not good at C#. And Python's a lot easier to access big databases.
Yeah, I mean, I can show you how long it'll take. I think I have it commented out here. If we change this to like half a million. Run it. Yeah. So that's half a million, and it got to 5 terms or 6 terms compared to the 16 that math.pi has.
Mm,
So definitely don't try and calculate pi by yourself.
no.
Just use
No.
math.pi.
Yeah.
The one concept here that is probably too advanced, and I doubt we'll actually see in a while, but I found really interesting is recursiveness. So the greatest common divisor between 2 sets of numbers, there's actually a process that I ended up Googling that I think it's this site. Yeah. Or no, it wasn't this site. Maybe it's this one, Khan Academy.
Oh,
Yeah.
nice.
So basically, like if you want the GCD of 270 and 192, you basically just keep dividing them, plugging in the remainder. So like you start with A and B, and then B becomes your new A, and the remainder becomes your new B. And you just keep doing that again and again and again until one of them equals 0, until B equals 0, essentially. So what I realized is like you're not going to. So this is like a chain of events of indeterminate length, right? You don't know that until you don't know how many times you have to divide by yourself until you know the result already, right? So I realized that in C#, a method, so when you define a method, so I defined GCD, can actually call itself within itself. So this returns the same method that I'm defining. And basically it like does this weird tunneling thing in the memory stack until it finds sort of the end result, and then it like rolls it all back up.
Mm.
And it's very confusing. It's very hard to wrap your head around.
You
But if you
find
guys
that
have time, look up recursiveness.
was it on Stack Overflow or like that you found this kind of stuff, or is that just like more mathematics?
So I've been introduced to the concept of recursiveness. So when I saw the Khan Academy thing, I was like, oh, that's what it is necessary. But actually implementing it, this was the first time in me trying to do something here. And that's why you can see some sort of comments here that I was like trying to figure out if it was working or not.
Yeah. The and when you say recursiveness, then you mean like a general control structure almost within lots of logics, or almost like a theory, or not theory, but like an application that you could probably use in other things too.
Yeah, and I don't think it's actually used too often, but the idea of a method calling itself is like recursiveness. Is my understanding of recursiveness, at least.
So yeah, it'd be like you could, well, maybe some other languages would allow it in certain ways too.
Yeah. And then in terms of part 6, I did not look at it enough. It looks difficult.
Would you say that's kind of like 9, 10, 11 would have been like just increasing in difficulty kind
of? In part 4 or part 5?
Sorry, I guess it would be like 1, 2, and then 3, 4, and then 5, 6. Like the way he originally planned to give it to us. Like the 5, 6, which would have been assignment 11, would have been like way harder than 10, which would have been a lot harder than 9. Or did you find 9 and 10 similar?
I found 9 and 10 relatively similar. Or no, so 9 was a lot
And,
easier. 9 was
okay,
easier than
yeah.
8 because 9 is covering stuff that we did in like weeks 4 to 6,
Yeah, yeah.
whereas 10
This has
covers
some new
stuff
stuff.
from like methods.
Yeah.
And then I think 5, like parts 5 and 6 here cover things that we haven't necessarily, we've learned sort of the basic building blocks, but we
Yeah, but
haven't
not
been
how to
exposed
combine
to
them.
exactly, we haven't been exposed
Yeah.
to some of the more
Structure.
creative aspects of programming.
Logic for what have you been doing any other stuff on your own? Like, yeah, I know you said you were trying to do some stuff within C. Have you made anything kind of cool?
Have I made anything cool in C?
Like, just I mean something that didn't come from class content. Just out of curiosity.
Oh yeah. So this is another sort of mathematical thing, so to speak. Apparently it's a relatively common coding question, though I think by now it's become more common knowledge.
You mean like an interview question? It used to be.
Yeah.
Yeah.
But essentially it's another way of approximating pi. So if you imagine a circle, so let's like, and this, we're getting into like actually our math course.
Okay, yeah, I was gonna say there is crossover for sure. Yeah.
But if you and my drawing skills are terrible.
Whatever. I get the idea.
You imagine a circle. In a box. So if this circle, if this is 1, so this is a 1. So this is 1, 1. This corner is 1, -1. This is -1, -1.
Your XY quadrants, basically, eh?
1. Yeah. So given this, how would you can you calculate pi? And the answer is yes. But the theory behind it is very interesting. So basically, what you do is you plot random points in this quadrant up top, in here. So you just plot points in this 1 by 1 square, right? And you're basically checking, are they on this side, or are they on this side, or are they on this side, right? And then the ratio between the two. So actually, before I get into that, because the formula for the area of a circle is what? Pi r squared, right? And then with a circle with a radius of 1 is pi times 1 squared, which is pi, right? So you know that the area of the circle is, like, the entire circle would be pi, and you know the area of the entire square, if it's this square, this 1 by 1 box would be 1, and then the area of this quarter circle is pi over 4, right? So then you have the ratio of pi over 4 to 1, and then you basically plot random points between these two, like you just a random number generator between the two, and then you classify them as whether they're in the circle or in the box, and then you can calculate the ratio of the two. So I found that super interesting.
The more you do, the more accurate it is, I guess. Or did you
Exactly.
choose rounds, or okay?
So if you do it multiple times, all right, so how many times to run? So like if we do it 10 times, it gets to 3.6, because it's probably plotted like a few points in over
inside
here, a
and
few points over
outside,
there, and all of that.
So it's like the ratio allows for approximation of pi basically, and the
Yeah.
more you add to the ratio, the better. Yeah.
Yeah. So like if I
more
ran
data in, the better.
100,000 times, it's 3.14,
Yeah.
which is a little bit closer.
And I guess by definition, if it was like pixel counted and you could run every pixel, technically you should get as close to accurate as you can, but because it's endless, it wouldn't be. But I just mean in terms of how a computer might do it for display or stuff like that.
Well, you're not counting pixels, right?
No, I know that, but I just mean if you could break it down to like an actual component level, but you can't, right? Like that's the because
Well, I mean,
you could keep increasing the number and it would always continue to increase its accuracy, right?
yes.
Yeah. Because it's like that curve idea. You're getting closer to true, but it's never going to actually hit.
I mean,
like almost like from that.
If I ran it, more times than my computer would survive,
yeah,
then I could probably get to a good approximation of
yeah,
pi.
yeah. Well, by all means, more than you need for most stuff you need to do, right?
Yeah. So I found this quite interesting. I'll share like a video of the sort of there's a fellow that explains sort of the theory behind how this works.
I was curious. I was like, did you figure this out on your own?
No.
I was gonna say that'd be insane. Yeah, no, I'd be interested to see it.
Yeah. So it was quite interesting. I enjoyed it a lot. I enjoyed learning the math a lot, and then I figured out how to implement it in C# myself. So it was quite fun. Definitely something I'm going to be exploring more during the break. But I just saw the time, and I know folks do have to get back to the day. I guess were there any other bits of the questions that folks had issues with that we want to dive into a little bit more detail, or is everyone relatively confident in what's it called in the assignment, at least, because that is the initial point of this chat.
This definitely helped clarify some stuff for me. Like I say, I haven't really gotten into it a whole lot, so if I have questions, I'll just reach out. But either way, I find the other stuff interesting as well. I was going to mention too, I don't know if Mona and Amina are interested, but Jason, I keep forgetting you to ask as well. But if you guys put your email in the chat, an email that you might want these sent to, there's a newsletter that I have that's like C# Digest, and it shares some pretty cool stuff. It's not really very long, and you can choose like monthly or weekly frequency. But if I have your guys' emails, I can just send you links for some of the stuff that I have seen like that I've found useful. I should just go into the chat. I guess I can find it in the chat from Teams, but if you guys put it in here, I'll copy it, save it. Actually, I'll just pull out of here.
Oh, Jesus. I was I was on a hardware mute. Yeah, I was on a hardware mute because I was eating a slice of pie and then I forgot to unmute myself.
You guys could hear me though?
I couldn't.
Oh, okay. That's okay. All I was saying, it was just I mentioned sending that C# Digest email. link to you guys.
Yep. Okay, we
The
got
girls
that.
just, yeah, the girls just shared their email, so I'll share it to them, and then I can pull yours from our chat, like the Centennial one, if you want.
Sure. Yeah, that'd be great.
Okay.
Alrighty. In that case, we can wrap it up. Again, have a great day, and feel free to message in WhatsApp if run into anything.
Awesome. Thanks, guys.
Thanks, folks. Have a good one.
Have a good day.